Okay, guys, this is Rajendra. I'll be the instructor for this webinar. Let me just give me a quick introduction. My name is Rajendra. I have more than 12 years of experience into the DevOps technologies, and from last more than 5 years now, I'm into the training field. Okay, so I do deliver training on the all the DevOps related tools like Git, Docker, Kubernetes, Ansible. There are a lot of tools are available. So this webinar, what we have planned is it's more about just giving a brief about what we do in the DevOps, what is DevOps, what are the most popular tools those are used in the industry. So just to give you a quick idea on that, and on top of that, everyone can decide what would be the path in the DevOps, the learning path in the DevOps. Okay, so that is what we are going to discuss here. So maybe we are planning this webinar for 1 hour, and last 30 minutes I'll give a chance for everyone to ask the question if you have any. Okay, perfect. So let's start. So as you already know about the Cognixia, and that's the reason you have planned to attend this webinar. So we have more than 150,000 plus professional trained worldwide. Okay, so 7,000 plus industry veterans. Those are part of the instructors. Okay, those are training all the technologies, not only DevOps related, but there are a lot of other courses are also available. And if you see, there are some partners that we have. We work with them to understand their technology as well as to train the people with those technology. And at the bottom side, you will see some certification that Cognixia achieved. Okay. Fine. So these are the few topmost courses that we provide. So you can just have a look at quickly. So the most popular nowadays, everyone is talking about the AI machine learning. Then everyone is moving from monolithic application development to the microservice application development. Okay, then we have a robotic process automation. We call it as RPA, and IoT, big data, DevOps, cloud computing, security. Okay, then there are some AI tools as well. So all these technologies are courses available in the Cognixia. So if you're really interested in any of this, definitely you can get in touch with the support team. They will help you out to understand more on that. So this is the topic for today's webinar. So in this, what we are going to understand, it's more about DevOps. Okay, what DevOps? Okay, what are the tools that we have? What are the best practices that we should follow in the DevOps? What are the tools most popular in the industry? Okay, so that we'll see step by step. So let's start with what is DevOps. Okay, so now you must have seen there are a lot of definitions. Everyone talk about what is DevOps. Okay, but to just easily understand, okay, if someone asks you what is DevOps, so in easy terms, what we can say is that DevOps is all about automation, right? So why we call it as it's all about automation? Because whatever the processes that we are following earlier, okay, now you must have already learned in the academics that if any software we need to develop, we have some standard steps that we follow, right? You must have already know that, like first we gather the requirement, right? Then we do some designing on that particular requirement. Then with some developers, we do the coding, then testing, then deployment. Okay, or maybe if we have multiple components, we do the integration, then we do the deployment, then we do maintenance, monitoring. All these are some standard steps we have for any kind of a software development, and those are still there. Okay, but why DevOps is required? Because what are the steps that we are earlier following and now also we are following, all those we are doing manually, right? So with the DevOps, what we are trying to do is we are just trying to automate all these processes. Okay, but yeah, still there are some processes like development. Okay, development is something we cannot automate, right? We need to write a logic. Okay, it's like we'll have some tool and that will write the everything for us. Okay, we don't have that kind of a technology deal, but yeah, definitely apart from development, like if you want to do some build up your code, or if you want to test your code, yes, there are a lot of tools are available through which we can automate this process. Okay, so in a simple terms, if you just wanted to understand, like what DevOps is doing is it is just integrating all the stages that we have in the software development, and we are just trying to automate all these stages with the help of some tools. Okay, and this overall process we call it as a DevOps. Now, if you see the name, okay, DevOps, okay, so it's a combination of developer and operation team. Now, when we say developer, okay, so it's a kind of like developer plus QA usually we see, right? It's not like only a developer. So it is just combination of, you can say, developer, QA, and the operations team, right? So DevOps team or the DevOps engineers are nothing but those are going to work with all these people to make sure the communication between all these teams will be smooth, and whatever the transformation that is going to happen for our product or the project, okay, there should be a proper communication between all these teams, and that communication or the process that we are going to define, that is with the help of DevOps tools that we have. Okay, so we'll discuss more on those tools or what is the standard DevOps lifecycle we have. But yeah, in a easy terms, if you just want to say someone like what is DevOps, so it's all about automation. Okay, automating our software development lifecycle. Okay, there is a lot of revolution happened in the DevOps. Like earlier as well, we are using some tools for the developing any software. Okay, so before DevOps, what was happening? Like every team was working independently, right? Like developer will work independently, then the QA, then operation team, and then business analytics team. So all those teams will work independently, and that due to that, what was happening? Like there was no proper communication between all these teams, and that's why the overall software delivery was getting delayed, right? Because like if developer do something, and if it the next QA team is not aware about any new changes that is introduced by the developers, definitely they will miss the testing of that part, and if they miss that testing of that particular part, what will happen? That problem may occur somewhere in the production, and if we find that problem there, then it is very costly. Like we need to maybe rework on that, or that will overall impact our business. So what if you see, like there are a lot of silos. Okay, silos means what? There will be a lot of unknown things if there is no proper communication, if there is something new got introduced. So this is what happening before, means if you are not using DevOps, this is what will happen. But when we start integrating the DevOps methodology, so it's not like one day we'll be able to do all the complete means in a one day we'll not be able to use or start using the DevOps. Okay, there are a lot of small things we need to consider, and we can start gradually. Okay, so that's the reason in the second level you can say well, like a team will define their DevOps agenda, like okay, in a maybe first phase, this is what we are going to integrate, or this is how we are going to integrate. So now for that purpose, all the different teams will start coming together, they will discuss the overall plan, and then they will start working. Maybe they will do that phase by phase manner. Okay, maybe in the first phase they will start integrating maybe some first 10 feature. Okay, then maybe next phase they will start integrating the next 10 feature. Okay, so this way they will start integrating the overall they will start interacting with all the team. So basically to do that, okay, we have a DevOps team, okay, that will make sure that whatever is getting delivered from the QA to the sorry, from developer to the QA, there should not be any new stuff. Okay, everything will be known to what QA wants or what developer wants. Okay, there will be a proper communication. There should be a proper tools that will be used, and that will help both QA and the developer to properly interact with each other and to share that information properly. Okay, or the DevOps team with the help of tools by writing some script or some files. Okay, they will make sure that whatever the gap was, that won't be there. Okay, so now this is the phase by phase steps. So you can see in the second step, all the different teams will start integrating with some manner or some phase by phase. In the next level, you can see they are more interactive, and in the nowadays, okay, when the team is having more interaction, or they are like working as a single team, okay, then we'll have overall product will have a more maturity, okay. Everyone will be aware about everything. So in the revolution, let me just quickly repeat here. So when we're talking about what revolution happened in the DevOps, so you can see in the first phase, when there is a no DevOps, all the teams will work independently, okay. Then gradually people, when any company wants to use the DevOps, okay, in that case the teams will start interacting with each other, okay. There won't be any gap as such, right? And then gradually they will start more interacting, and at the end, nowadays those companies who are using DevOps heavily, okay, there won't be any means they won't have multiple teams, okay. Everyone is working as a one team, okay. You will not find that, okay, the developer team will is working separately, QA team is working separately. So nowadays those companies who are using DevOps for so long, it's, you will find that the whole team is like only one project team, okay. Definitely they will have some developers separately, QA separately, but then they will work together, okay. And that is where will not find any gap or any runtime surprises, because now everyone is aware about all the processes, or whatever is newly introduced, it will be aware for everyone now. So this is something we call it as a DevOps lifecycle, okay. So now instead of showing it here, let me just draw it on the whiteboard, okay. This will give some more understanding. So basically, when we say DevOps, let me use some different color. Okay, so uh, everyone knows about the software development lifecycle, right? So basically in the software development lifecycle, we have some standard stages, like we do requirement gathering, right? First, what we do is a requirement gathering. In the next step, what we do is we do the design, right? Like from the client, okay, we'll get some XYZ requirement, okay? Just for an example, let's say our client is Flipkart, okay. So now Flipkart will come up with a requirement like, okay, this is how my website should be looking. I should have on a single page 10 products should be listed on the left hand side. I should have this kind of a panel. On the top side, I should have this many tabs, okay. Under this tab, this many sub tabs should be required, okay. Then I should have this kind of a payment gateway, this kind of offer, okay. This kind of UPI gateways, right? This my card should be looking like this, okay. So all this kind of a requirement client will give to us, right? So now once that requirement comes, okay, what we do, we do the design for that, okay. In a design we decide like, okay, what all the components we require, what is the programming language we are going to use, what is the database that we are going to use, okay. So all those discussions, all the component communication, you must have heard about the UML diagrams, okay, where we do the create the some sequence diagram, class diagram, object diagram, okay. So all this kind of design will happen in this design phase, right? So once design is ready, okay, we'll have some developers for with a different technology understanding. So as per their task, okay, the whatever the design is given from the architectures, okay, the developer will start working on that. Okay, they will do the coding for that. So once coding is done, okay, the next thing that we do is a testing. So in a testing, we'll see that, okay, whether we are able to log into the Flipkart website, okay, whether we are able to select the product, we are able to check out the product, we are able to do the payment for that particular product. So all this kind of a testing will happen, right? So once all the test cases, those are, or what we say, like usually client gives us the some acceptance criteria, like this is how it should be. If this we get it, we'll accept the product, okay. Just that kind of a acceptance criteria will be decided, and depending on that acceptance criteria, all the test cases will be designed by the testing team, and those will do the testing. And once all the test cases are passed, what we do is we do the deployment, okay. Now in the deployment, we have to think of like, okay, what will be the environment, how many machines we required, how many instances of each application required, is there any load balancer required, how we are going to uh, deploy the database, is there any cache service required, okay. There are a lot of things need to be considered. and that is where the deployment phase will be there. Okay, so now once deployed, okay, once deployed, definitely we need some maintenance, right? It's not like, okay, we deployed the product and that's done. Okay, we don't need to do anything on top of that. Definitely we need to do upgrade. Okay, we need to do some more upgrade of the softwares, or you need to upgrade our Flipkart website itself. So there are a lot of things need to be done, and that is what we cover in the maintenance. And then the very important step of software development lifecycle is the monitoring. Okay, so monitoring is somewhere we should have a view of how our application is doing. Okay, so if we don't have a monitoring, then like we may not be able to get a problem early. Okay, until unless some whole system gets broke down. Okay, if we don't have a monitoring setup. But if we have a monitoring environment, a monitoring and alerting, where as soon as there is some maybe let's say you have deployed on one machine, and we have given a monitoring mechanism where we'll say that, okay, if a CPU utilization on this particular system goes above 80%, inform me so that I can upgrade overall compute capacity of that machine, right? But if you don't have a monitoring, definitely until and unless the capacity is going above 80, 90, 99%, will not be able to get idea, because by that time our whole application may be down, or no start will not respond, because that system itself got hung, right? So this monitoring also very important, because if we have monitoring, then only we'll get an indication of a problem very early, and that is where we can quickly rectify that problem, and so that our system will not go down, right? So monitoring is again a very important part. So these are the very standard software development lifecycle. Still everywhere it is getting followed, right? But all this was happening manually. Okay, without DevOps, all these are happening manually. Okay, definitely we are doing some automation here, but still it's not that complete automation. Okay, so like every phase is having their own automation. So with the DevOps tools, what we are trying to do is we are just trying to automate the whole process. Okay, so that is what we are going to discuss now, how we are going to achieve it. So basically, obviously, for a requirement gathering and for the design purpose, these are the two stages where we need a very active participation with the client, so that then only will everyone will be on the same page. Okay, so definitely for the first two stages will not have any automation. Okay, so there will be a lot of tools for trying a lot of stuff, but yes, still those are something we do manually. Okay, it's not the complete automation. But from the again in the coding as well, definitely it's again a manual process. But let's say we have some developers. Okay, so developers are doing the coding, but as soon as developers are done with the coding and they are putting the code somewhere on the source code management. Okay, so this is the first step of your DevOps lifecycle. Okay, so source code management tools like Git. Okay, Git is something that is a part of our DevOps course. Okay, so this is why we have chosen this, because it's a very popular tool, and almost it has more market share nowadays, because almost 60 to 70% companies are using Git as their source code management tool. So what this tool is doing, this actually maintains the, if there are a lot of developers are working on some project, so this source code management tool will maintain their code. So now what we are doing in the DevOps is, as soon as there is some code push happens here, okay, as soon as there is some code push happens, automatically what we do is we copy that code, okay, that source code on some build machine, okay, on some build machine where we can build that code, right? So now why we need to build it, because this is a raw source code that is going to be developed by the developer, right? So it's not like, okay, we ship that complete source code on the client side and we'll run that source code. Okay, so this is not something is expected. So what we do, we build that code and we'll get the some final package. Okay, maybe let's say this code is written in a Java. Okay, just for an example, this code is written in a Java. So when you build your Java application, it gives us some jar file or war file. Okay, it's a single file. Okay, if you run that single file, your whole application will run, right? So to get that single package, we need to build our application, and there are a lot of build tools are available Okay, but the more popular tool, that is Maven. There are some Ant, Gradle, there are a lot of other tools, but again, this build tool, it's completely depends on, this build tool is completely depend on what programming language we have used here. So every programming language will have its own build tool, right? So mostly for a Java, Maven is something which is popular. So this Maven tool will build the code that is copied from source code management to some build server. Okay, we'll have some machine where we'll copy that source code, we'll build that code, and at the end we'll get some final jar file. Okay, so this is what we'll do in the second step. In the third step, we'll do the testing of that code. Okay, so let's say this Flipkart website we have built or created using Java, and that we will have some test cases. Okay, so here automation testing team will come in picture, where they will write some automated test cases, and as soon as the build code is ready, okay, we'll copy that final jar and we'll run that here. Okay, we'll run that here, and then we'll apply some automated test cases on this. Okay, and then we'll get the result like, okay, out of 10 test cases, 5 are successful, 5 are failed. So now okay, so now we'll continue on that. But let me just give one quick scenario here. Okay, so let's say why DevOps is getting popularity and not the and why not the earlier approach. So in the earlier approach, what was happening? Let's say there are some developers who are doing some development. Okay, so let's consider on the day one they are done with their coding. Okay, they are done with their coding. So let's say they are done with the coding at the end of the first day. So obviously once they are done with the coding at the end of the day one, the testing team or build team is not going to work on that. So they will come on a second day. Okay, on a day two, let's say they will build that code and test it. Okay, so that means at the end of the day two, we'll get some result. Let's say on the end of the day two, out of 10, 5 test cases got passed, right? So at the end of the day, this is what the result we have. So now again on day two, the developers are not going to work right away, because at the end of the day they got the details that, okay, the 5 test cases are still failing. So what will happen? The developer will come back on day 3. He will fix those 5 bugs. Then let's say consider on the end of the day 3. At the end of the day 3, we got at the end of the day 3, the testing team got that product. Okay, so what will happen? Testing team will come back on day 4 and they will test. Okay, and let's consider on the day 4 we got 10 out of 10 cases passed. So here you can see a normal software is taking 4 days to release it. Okay, 4 days to release that. But with automation, okay, with the DevOps, what we are going to do, let's try to understand here. Okay, so here what will happen? As soon as build is done, the final jar will copy, and once that is copied, automated test cases will be running, and once those are done, let's say here we got, let's say on the first attempt we got the 5 out of 10 test cases are running. So this process is automated. So how we automate? So we have one tool called Jenkins. Okay, so we have one tool called Jenkins. So what this tool is doing? This tool is nothing but we call it as a IT automation tool. We call it as, okay. So what this tool will do is it will try to automate this process. So in this Jenkins, what we do is we create the jobs. Okay, we create the jobs, and then every job will have some specific task to be done. Okay, so what will happen? This job 1, let's say we have written some script for job 1. The task of this job 1 is to as soon as there is a commit, copy that code from the source code management server to the build server. Okay, it's a task of this job 1. Okay, then we'll have another job. What is the task of that job 2? Is to whatever the code is copied, just build it. Okay, then we'll have a job 3. Okay, that job 3 is the task of that job 3 is whatever the final jar is there, just copy that, run that jar here, and then run the test cases on that. Okay, and this we have some mechanism through which we can trigger one after another. Okay, one job after another. So what will happen? And we also have some notification mechanism. Okay, we have some notification mechanism. So what will happen here? As soon as the developers run the code commit, automatically this job will get triggered. That will copy the source code to the build server. That build job 2 is will build that code, and then job 3 will copy that jar and it will run the test cases. Okay, and whatever the result of that test, it will just copy that result. Sorry, it will inform that result to all the stakeholders. Okay, whoever is involved, like developers, testers, or managers, team lead, all the people involved, it will give that information here. So what will happen? And this process is automated. So as soon as on the, let's say on the day one, at the end of the day one itself, developer done the coding, okay, within a 5 minutes, okay, this process will run and we'll get the result that okay, 5 out of 10 test cases are failed. Okay, so here what was happening on the day 2, the testing team was working. Okay, but what will happen in this automation on the day 2, developers will come back and they will start rectifying those 5 failed cases. Okay, let's consider on the day 2 they will fix that. So end of the day 2 itself will have the result of 10 out of 10 test cases got passed. Okay, so you can see overall half of the time we are reducing, okay, to deliver that product. But how this is possible? With the help of this automation tools. So here what are the tools that we discuss? Like, okay, the Git is something which is a for source code management. Then Jenkins is something to automate this whole. Then for build we are talking about the Maven, and then for testing we can use some Selenium, okay, then Cucumber. There are a lot of tools are available. So for testing purpose we can use those tools. Okay, and this process we call it as a continuous integration. Okay, so this process we call it as a continuous integration. Why continuous integration? Because you can say this is a continuous process. As soon as developer do the commit, the code will be pushed. Okay, and then we build that code, test it, and the result, share the result with them. Okay, so this is what will happen, and this process we call it as a continuous integration, right? Now this is a half a story. Okay, let's consider once 10 out of 10 test cases are done. Okay, once 10 out of 10 test cases are done, what will happen? We'll have some job. Okay, we'll have some job. Let's say job 4. The task of that job 4 is to create an environment for setup. Okay, let's say some machines we required for deployment for our application. Okay, so definitely for the deployment, it's not on a one machine we are going to deploy. Okay, definitely for a testing purpose or maybe unit testing purpose, we can definitely do it on a single machine. But when we are going to actually deploy it in the production, it's not only one machine. We might have hundreds of machines depending on how big our cloud base is. Okay, sorry, client base is. Okay, how big our website is. Okay, so definitely on our Flipkart website we cannot deploy it on a single machine. Okay, we might need thousands of servers where we need to deploy it. Okay, which we have some load balancer. Okay, there are a lot of components we might require. So in a deployment phase we need to consider all this scenario. Okay, we need to consider all this scenario. But for to create all this environment, okay, to create this whole environment, we can create this environment using Kubernetes or Docker. Okay, Kubernetes or Docker we are going to use for this deployment phase. Okay, and we'll have some job that will do the deployment on all the machines as okay. So we need to write a lot of scripting, some script playbooks that we need to write. So all this we need to do. Okay, so that is where the deployment stage comes in. Okay, and in the deployment we use a Docker and Kubernetes. Okay, so once it is deployed, okay, once it is deployed, we need to set up some monitoring mechanism. Okay, we need to set up some monitoring mechanism for this deployment environment, so that if there is any challenge in the deployment, we'll get that information on the some monitoring environment. Okay, so for monitoring there are some tools like Prometheus. Okay, nowadays this Prometheus and Grafana is something which is very popular. Okay, but yeah, there were still some tools like Nagios. Okay, Nagios is something again very popular. Okay, Nagios. Nagios is a tool which is again used for a monitoring purpose. Okay, but nowadays Prometheus and Grafana it's more popular. So these tools are for monitoring. Kubernetes and Docker is for the deployment. Now there are a couple of more tools which are again popular. Okay, one is Ansible and another one is a Terraform. So where this tools comes in picture. So Ansible is an configuration management tool. Okay, Ansible is an configuration management tool. So what this tool is doing, so let's consider in the deployment you have 100 machines. Okay, so now and you want to deploy a Java application on those 100 machines. So it's not a good idea to install a JDK. Okay, the JDK is an, for Java, to run a Java application we need to have a JDK installed. So it's not a good idea to install the JDK on all the 100 machine by individually logging to that machine. Okay, so we should have some automated way through which we can do this JDK installation quickly. Okay, or even maybe after some time you need to upgrade your version. Okay, let's say now you have installed JDK 8 and you have to upgrade that to JDK 11, right? So if you want to do that, obviously it's not a manual task you want to do. Okay, it will take a lot of time to upgrade your 100 machines. Okay, so that is where this configuration management tools will help us to do that installation. Okay, and so if you write single file, or we call in an Ansible term we call it as a playbooks. So if you write that playbook, it will do the task in the background to configure all those 100 machine as per our requirement. Okay, so that is where Ansible is something will be used. So there are some competitors for Ansible, like we have Chef, okay, and Puppet. Okay, all these three are a popular configuration management tool. But yeah, again, the Jenkins is something which it's nowadays it is getting a lot of popularity and everyone is moving to that. But yes, there are Chef and Puppet. These are the some another configuration management tools. Those are used. And there is another one which is nowadays getting popularity called Terraform. Okay, so this Terraform is an infrastructure provisioning tool. So infrastructure provisioning means what? Nowadays a cloud is getting popularity. Okay, like everyone is trying to use the someone else's hardware. Okay, no one wants to use their own hardware, or nobody wants to invest in buying the hardware. Okay, because if you buy the hardware, it's kind of a like a capital cost you have. Okay, you have to invest in that hardware. So everyone is what they are doing is they are just converting that capex to opex. Okay, operational cost means they are just using someone else hardware for on a just pay as you go basis. Okay, so let's say for a deployment you need 100 machines. So now if you need those 100 machines, so either you have to buy those 100 machines, okay, then configure using Ansible and then use it for deployment purpose. Okay, so that is one option you have. Okay, so if you are able to buy the 100 machine, well and good, you can go with that approach. But what if you just want to use those 100 machine from the AWS, or for that matter from any other cloud, right? If you want to do that, definitely creating 100 instances on AWS is again will require some effort. Okay, and that is where this Terraform will come in picture. Okay, so Terraform is an infrastructure provisioning tool. Okay, that will help us to create all these 100 machines required for the deployment. Okay, then we can use Ansible to configure those 100 machines, because if once you create the machine, we need to do some prerequisite installation all those on all those 100 machines. Like we talked, for starting the Java application, we need to have some Java dependencies to be installed. Okay, and that is where we can use Ansible to install those dependencies. So this is where this Terraform and Ansible will come in picture. Okay, and when we our all the test cases are done and we automate this deployment process, we call it as a continuous deployment. Okay, so these are some terms that we have in the DevOps. Okay, so if you know, or if you just learn all these tools that we talked just now, so what are the tools that we just now talked? Okay, so we talked about the Git. Okay, so Git is something, it's a source code management tool. Then we talked about the build tool, that is Maven. Okay, so there are a lot of other build tools as well, but Maven is something which is more popular. Okay. Then we talked about the Jenkins. Okay, Jenkins is something which will help us to connect all this tool or automatically trigger all this tool. Okay, so these are some tools that we have. Apart from this, we talked about the Docker and Kubernetes. Okay, so Docker and Kubernetes is something which is nowadays very popular. Okay, I'll just quickly give a brief on that Docker and Kubernetes after this. So this is something which is very popular, and for now we don't have any kind of a replacement or any competitor for this. Okay, so these are two nowadays. It's a very important to learn for everyone. These two tools. Then apart from that, for a monitoring, we talked about either Prometheus, Grafana, or Nagios. Okay, so these are the tools which are very popular. And then finally, for configuration management, we have a Ansible or Shape or Puppet, and for infrastructure provisioning, we have a Terraform. Okay, so if you know all these tools, okay, that is what every DevOps engineer should be aware about. Okay, at least this tool. You will find there are a lot of tools are available. Let me go back to the PPT. So you can see these are some tools you can see in every phase that we use. Okay, so even for Git as well, there are a lot of competitors we have, like Perforce we have, SVN we have, GitLab we have, okay, GitHub we have. So there are a lot of tools are available. For again, for build purpose as well, you can see we have a Gradle, we have a Ant, IBM Rational we have. Okay, so there are a lot of tools you will find in the configuration as well. You can see Shape, Puppet, Ansible, Vagrant. Okay, then for testing purpose, you can see JNet, Cucumber, SonarQube, Kerit, BlazeMeter. There are a lot of tools out there. Okay, but the tools that I have talked, okay, just now, those are very popular. Okay, almost at least 60 to 70% these tools are used. Okay, and then other tools having very less share in the market. Okay, perfect. Okay, so this is all some DevOps lifecycle stages that we talked about. And this is something we call it as a CI/CD pipeline workflow with the Kubernetes. Okay, so you can see here the developers will push the code in the Git repo. As soon as they push it, we build that code. If we want to deploy it into the Docker or Kubernetes environment, we need to create a Docker image. Then we need to run some test cases. Okay, we need to push that Docker image to some repository. Okay, then in the Kubernetes environment, we need to create some Kubernetes object for the deployment of our product. Okay, then we should have some monitoring mechanism that will monitor the product. Okay, so that is what we talked there. Okay, so now what I'll do, I'll just quickly show you the some small demo here. Okay, and then I'll open for the question. Okay, if you have any. So what I'm going to show you here is, so I have just a simple Kubernetes 3-node cluster. Okay, so we have some utility called kubectl. Okay, through which we can access the cluster. Okay, so if I run the kubectl get nodes, okay, so this command is just giving me the returning me the status of the cluster and how many nodes we have in the cluster. So I have a 3-node Kubernetes cluster. That means I have 3 machines. Okay, one machine is something which is responsible to manage the cluster, and there are actual 2 machines where we can deploy our code. Okay, so this is the smallest possible cluster. Okay, in the production we might have you can see there is one control plane and there are 2 worker nodes. Okay, in a production we might have one control plane and we can have hundreds of worker nodes. Okay, so those worker nodes we can use to deploy our applications, right? And to deploy that application, we have this Kubernetes environment, and to interact with this Kubernetes environment, we have this kubectl utility. Okay, so under this kubectl utility, you can see there are a lot of commands we have available, right? So let me just quickly show you. I'll just create one small deployment here. Okay, so what I'm going to do is, there is a one Nginx image I have. Okay, and that image I'm going to deploy, and I'll just quickly show you how easy it is in the Kubernetes environment if you just want to scale up, scale down your application. Okay, so let me just create it. So commands are very simple. Okay, you will get all that details or a lot of documents to read about it. So if you see kubectl, we have a command kubectl create is a command. okay, and then we have in a Kubernetes we have one deployment object. Okay, we have one deployment object, and let's say that deployment object I'm giving it as a nginx. Okay, and for that I'm going to use the image as nginx, right? So this is how I'm just creating this deployment. It's a very simple. So either you can write a configuration file for this, or you can use the imperative command, the one that I have used, okay, and through which we can create the deployment. Okay, so you can see if I create kubectl get pod, so you can see under that nginx one pod got created. Okay, if you see more information about it, you can see here this is got deployed on the kind worker 2. Okay, so we talked about there are two nodes. Okay, in fact there are three nodes, but out of that worker node we have only two, but out of that on the kind worker 2 our application got deployed, right? So now let's consider we have deployed an Flipkart website on this particular node, okay, and we just created only one instance. Okay, so how we decide how many instances required to be created for your application? So usually if we have one machine, okay, every machine is having some compute capacity. Okay, when I say compute capacity, that means it's a RAM, CPU, and it has some hard disk. Okay, so when I say compute capacity, means these are some components we call about. Okay, so every system is having some capability. So now if I deploy the application, it's not like system is having unlimited compute capacity. Okay, it has some limited, maybe let's say 2 vCPU, 2 GB RAM. Okay, that kind of a limited capacity we have on this machine. So obviously the application running on this, it also will have some limitations. Like let's consider if this is a Flipkart website we deployed here. So if due to some system limitations, let's consider that the application running on this machine can access or can process 100 requests per second. So this system will keep working fine, okay, till 100 requests are coming per second. But what if we are getting 200 requests? Obviously one instance of your machine is not going to be enough, right? So you might need to have another instance running. Okay, and then we can have some load balancer where some requests will be sent here, some requests will be sent here, right? If you are getting 200 requests, so now that 200 requests will be processed if we have a two instance. So let's consider for now you just deployed two instances and your website is working perfectly fine. But now there is a Flipkart sale we have. Okay, so we have must have seen a lot of sales in the now. We have some festival seasons coming in, so we have a lot of sales coming in, right? So now if there is a sale, obviously overall traffic that is going to be there on the Flipkart website, that is going to be increased, right? So if that is going to be increased, definitely let's consider that traffic would be like now thousands requests per second. So obviously just having two instances is not going to be enough. Otherwise what will happen, your website will get crashed, right? So you must have heard the news like there's a lot of traffic on the website, and due to that users are not able to book their product or buy their product. That kind of a news you must have already seen. So why that is happening? Because there is a lot of load on the website, and due to that reason the website is not able to respond to your request. Okay, so definitely that is going to happen if we increase the number of requests to 1000. So for that reason, in a deployment environment, we should have a scaling mechanism, okay, where you should be able to easily scale the number of instance from 2 to maybe now we have a 1000 requests coming, so we should have a 10 instance. Okay, we should be able to easily scale from 2 to 10, so that whatever the new or whatever these 1000 requests are going to come per second, those will be processed. So Kubernetes is something, okay, which will help us to easily scale our application, scale up or scale down. It will help us, or it is providing that kind of a functionality for us. Okay, so that is also again with a zero downtime. Okay, that is also again with a zero downtime, means when you are scaling up or scaling down, user will not face any kind of downtime. Okay, they will be able to access the Flipkart website. Okay, so similarly, Flipkart, sorry, this Kubernetes is also providing feature like zero downtime upgrade facility as well. Okay, where let's say your Flipkart is perfectly working fine, and then now they have developed a new UI for your Flipkart website, and now they want to release that particular new UI. So definitely earlier you must have seen like before 2010 or 15. You must have seen the websites are down for some time. You must have got the message like application is down for maintenance. That kind of a message you must have seen on the website. But nowadays with the Kubernetes, we can upgrade our application without any downtime. Okay, in a zero downtime, we can upgrade your application. Right? Kubernetes is providing that facility to do that, because nowadays everything is digitized, every business is on the web, it's like on the cloud. Everyone is accessing the business, and if you want to give some downtime to your business, definitely you are going to lose the business. Okay, whatever the revenue you are going to get generated, if your even website gets down for some time, you'll face a lot of revenue. Okay, recently we have seen like WhatsApp and some services of Facebook are also down, right? So we must have seen the news like Zuckerberg, that revenue got, this particular company revenue got down by this numbers, right? That kind of news must have heard. So definitely, if you are nowadays, if you are giving a downtime to your application, you are going to lose some business. Okay, and that is where Kubernetes is something which is providing a mechanism where you don't require any downtime. So definitely there are a lot of other features as well Kubernetes provides. So we will talk about all those features and all in more detail when you register for this course, and we'll try to understand more about Docker, Kubernetes, and some other DevOps tool. But let me just quickly run a couple of commands to show you how you easily you can scale it up. So right now you can see there is only one instance of this pod is running, right? So if you just want to scale it, how you can scale it easily, even you can make it automatic as well. So how I'm scaling it, kubectl scale, what you want to scale, the deployment nginx. Okay, and we have to specify how many replicas we want. Okay, so let's say from one instance you want to make it as a 10. Okay, so if I run it, and if you just see kubectl get pod, you can see behind the scene there are 9 new containers got created. Okay, so total 10 replicas of our application started running. Okay, so you can see still one is creating. So you can see now we have 10 replica of the same applications are running. Okay, so within a few milliseconds, okay, our application got scaled, right? So even if now we get 1,000 requests to your application, still our application will respond perfectly, right? And let's say once your Flipkart sale is done, and you want to scale down it back, so you can just, let's say, scale it down to 1. So within a one command you can do that. So now you can see other replicas will be terminated, and we have only one replica running. Okay, you can see only one replica is running. So this is how easy it is to be done. Even we can make this mechanism automated as well. Okay, we can use some metrics like, let's say, CPU utilization. So you can set up some, in Kubernetes we have one component called horizontal pod autoscaler. So what this component is doing, it is just scaling up and scaling down will be automatic on the basis of CPU utilization. So we know that like if your application is getting a lot of load, obviously it is going to consume more CPU, more RAM, right? So and if it is getting increased, so what we can do, we can have mechanism that will say like if CPU utilization is going above 80%, just increase the one pod, okay, or increase the one instance, right? So again for the second pod, if the utilization is going above 80%, again increase one pod. So even we can make this as an automated mechanism as well, where you don't need any manual intervention. Automatically a new instances will keep creating. At the end you will have a whatever the new load is coming, that will be processed automatically. And once if your load is going down, automatically that horizontal pod autoscaler will reduce the number of instances. So obviously if you are going to reduce the number of instances, overall the compute resources that we are using, that will also be reduced. Okay, so this is a simple feature or the most popular feature about the Kubernetes we are talking, but there are a lot of other features also available in the Kubernetes. and we will talk on those features as well in more detail. Okay, but just to give a quick idea how Kubernetes works. Okay, so I just have given this quick demo about the Kubernetes. But yes, there are a lot of other tools as well. We are going to see the complete overall picture about all these tools as well, where all these tools we can integrate and we can see overall our software development life cycle with the help of DevOps as well. Okay, fine. So that is what I wanted to talk for today's session. So thanks everyone for joining.